Hey, 8th graders, if you are watching this, you have successfully found the answer key video for the Newton's third law worksheet. We're just going to go through in this video the modeling tool, so you guys will kind of notice if you look over to the left here that we're missing quite a bit of slides, so you guys won't see the bell ringer on here, you guys won't see the sim on here. But you guys will see the answers to the modeling tool, because just like in chapter 1, you guys will have part of your assessment grade B, a modeling tool that shows what happens when the space pod hits the space station. Okay, so let's just go ahead and get right into it. As I kind of talked earlier, you guys can use the sim to kind of help you, but it isn't very black and white. So as you guys go through this answer key, keep in mind that you're not going to see necessarily the exact same slides of what you guys did. So it's really important that you guys listen to this so you understand what the force would look like when two objects collide and what the velocity afterward is going to look like, because that's what you're asked to do in these modeling tools. So in the video, I already did the example for you guys. So you were supposed to model the during force. So even though these two objects are small and they're both moving at each other with a small velocity, we're going to see the exact same force when they collide. So the second those two objects are hitting each other and in contact, this one is putting an object on this one, and then this one's putting the exact same strength of force on the second object, but in a different direction. Okay, so those two arrows are equal in size but opposite in direction, and then because they're both the same mass, we're going to kind of just see them swap velocities. So this one, which is moving to the right, is now going to show this one moving to the right. This one, again, is what this velocity was doing. So because of the same size mass, you're going to kind of just see them swap velocities. Okay, here we go. Here's another one where they're the same mass. So this one's moving to the right with a medium velocity. This one's at rest. When they collide, you guys could have put a small force on there. You guys could put a large force, whatever the case is. But what you should see is that those two arrows are equal in size but opposite in direction. Okay, so again, whatever size arrow you did, that's fine, as long as it shows that they're the same size and that they're opposite in direction. Okay, and then because they're the same size object, you guys see that in the after force that I gave you, they just kind of swap velocities. Okay, so keep those things in mind as we move forward. That is an exact answer key that you guys are following, but the concept that when two objects collide, no matter what their size is, they put an equal force on each other, but in an opposite direction. Here we got two of the same mass objects, both large. The right one is moving to the left with a large velocity. When they collide again, maybe you guys put a medium velocity, maybe you guys put a small force, but when they hit each other, they're going to have the same size pink arrows. So I put large for this one. If you put medium, that's fine, as long as they're both medium and they're in opposite directions. Okay, and then again, these two velocities kind of switch spots. So this one's going to start moving to the left. This one is going to start moving. Okay. All right, this one, we've got, again, two same size velocities. So this is number 3. When they collide, you guys should, again, I put medium on here because maybe these objects are moving a little faster, but if you guys put small or large, that's fine too, as long as they're both the same sized arrow and in opposite directions. And then in this one, you guys are modeling the after force. So again, because these are the same mass objects, they're going to kind of switch velocities. So this object was moving to the left with a small velocity. Now this one's going to be moving to the left with a small velocity. This one was moving to the right with a large velocity. Now this one's going to start moving to the right with a large velocity. Okay, number 4, you guys are doing after force here. This one was moving to the right with a small velocity, and then this one stopped. When they collide, again, I showed you guys that they have equal strength forces, but in opposite direction. This one's going to stop moving. This one's going to start moving to the right with a medium velocity. So again, they kind of flip-flop because of the same mass. Okay, this one, again, 2 more of the same mass. You're doing the after force, so moving to the right with a large velocity. When it hits this one, it's going to start moving to the right with a large velocity. This one was moving to the right with a small velocity. Eventually, this one's going to catch up to it, and when they collide, this one's going to slow down and be moving with a small velocity also to the right. Okay, so notice, again, in the during force, the arrows that I gave you are the equal size, but in opposite directions. Okay, number 6, again, after force for this one. Small objects, both same mass. This one's moving to the right. This one's moving to the right as well. Eventually, this one's going to catch up and hit this one. So whenever they do collide, you're going to see equal forces here, which I showed you. They're after movement because of the same mass. They're just going to kind of flip-flop velocities. So now this one's moving to the right with the small velocity. This one's moving to the right with the medium velocity. So opposite of what they were doing in the before force. Okay, now we're getting into some where we have different masses. Okay, for these, you're going to do both the during force Okay, and also what do they do after force? So again, this isn't going to be exactly like mine. If you did it a little differently, that's great, but what I'm looking for is, can you correctly model the size of the force and the direction of the force? And can you show me how they have different changes in velocity after the collision? Okay, so this one's moving to the right with a medium velocity. It is a medium force. This one's at rest. So when I look at the force on this one, I'm going to choose medium, but if you chose large or small, that's fine. It doesn't matter that one object has a lower mass than the other one. Okay, when they collide, they're going to hit each other with the exact same force. So I chose medium. You guys may have chose large or small, but whatever you guys chose, you should have two pink arrows that are opposite in direction, okay, but are the same size. So I picked two medium arrows. Okay, so even though this object is smaller and this one's larger, they still hit each other with equal force because of Newton's third law. Okay, and then after this, because this one's heavier, we're going to see a smaller change in motion. So maybe this one's only moving to the right with the medium one, and this one's going to start moving, and maybe it's going to start moving with a medium velocity. Maybe you guys put large velocity. What you're going to see though is this one's going to see a bigger change in motion. This one maybe slowed down a little bit. Maybe it didn't even switch directions at all. Maybe it went this way, but we're just going to see a small change with the medium and then a larger change of velocity with our small object. So that's kind of what you guys are looking for there, is equal arrows but in opposite directions, and that our small object is showing a bigger change in velocity because it was stopped and now maybe it's buzzing off. This one could even be large. It doesn't really matter as long as you guys show that this lighter object is going to have a much more rapid change of motion or a bigger change of motion. Okay, whereas the larger object's gonna kind of show less of a change of motion. Maybe it just speeds up a little bit, maybe it slows down. Okay, next object in the during force box, use the pink arrows to model the force. And then in the after force, again, show what it looks like after. So I had my small object moving to the right with a large velocity, and I had my large object also moving to the right but with a small object velocity. So when these two collide, I just chose a large force. Again, you guys could have chose small or medium as long as those two pink arrows are the exact same. Even though this is smaller and this is a large object, they're gonna hit each other with the same force. Okay, so they're just gonna see a bigger change, so bigger effect, if you will. The cause is that they have the same force. The effect is going to be different because they're a different mass. So here's our cause, is these two pink arrows that are exactly the same but in opposite directions. Okay, and then for this, I mean, it was moving to the right with a large velocity. Now I have it moving to the left. That's a huge change in motion, and that's what I should see with this small object, especially colliding with a large. The large, you guys maybe see it speeds up just a little bit, but truthfully, I would have that it's still moving like pretty slow, okay? It'll speed up maybe a little bit, but not very much. So if you guys did like the small or the medium velocity, that's totally fine. Again, but what I should see is this hardly has a change of velocity. This one's gonna have a huge change of velocity. Again, think of a shopping cart that's empty hitting a vehicle, okay? The vehicle's hardly gonna have any change, but the shopping cart's gonna have a pretty big change in its velocity. And, you know, even though they're colliding, they're hitting each other with the same force. It's just a big change that you see afterwards. Okay, so any of those examples kind of work. This one is the last one. You guys are doing, again, the during force and the after force velocity. So I've got a medium object. This is going to be similar to what we see in the space pod, where we have the pod moving to the right with a small velocity, because remember, it was a little bit heavier than normal. When the thrusters kicked on at its medium force, it only slowed it down, it didn't stop it. So here's our medium object moving to the right with a small velocity. And then eventually it's gonna collide with the large space station, which is technically at rest. So when I modeled this, again, you guys could put two large arrows here. That's totally fine. Even though the medium space pod is a smaller mass than the large, they're going to hit each other with the same force. So if you put two large arrows, that's fine as long as they're the same size arrows and pointing in opposite directions. You might have even put small. That's fine as long as they're both small arrows and they're moving in the opposite direction. Okay, and then what we're going to see is a bigger change in the medium. So it was moving to the right with the small velocity. Now it's kind of cooking away with the medium. You might have put a small, that's okay. And then our large object, which was at rest, is only going to just start moving to the right slowly. So bigger change for our medium object, a small change, but a change no less for our large object. So again, that's what I'm looking for. Your answers might vary just a little bit, but what I want to see is that your medium object is showing a bigger change in velocity than this guy here. Okay, so then you guys should have completed your exit ticket. I hope if you guys have any questions, please let me know, and I will talk to you soon. Bye.